Hello everyone, today I'll be solving the Chemistry S May-June 24 paper 12. So let's get started. Which pair of formulae is correct? Okay, so this is just testing your basic knowledge in radicals and valencies. Ag has +1, CO3 has 2 minus, so when you cross them over this is valid. NH4 has +1, NO3 has -1. When you cross them over this is not valid, A is wrong. HCO3 bicarbonate ion has a -1 charge and K has a +1, so when you cross them over this 2 is not correct and B is not correct. Ag has +1, HCO3 has -1, so this is valid. K has +1, PO4 has -3, when you cross them over this is also valid, so C is the correct option for now. Zn has +2, CO3 has -2, when you cross them over they cancel out because like they're the same, so you simplify them, and so this is valid. PO4 has -3, NH4 has +1, so this is a 2, this is not valid. D is wrong, so the answer is C. Second question, how many molecules are present in 62 grams of solid white phosphorus P4? Okay, so the number of moles, to find the number of molecules you have to multiply the number of moles multiplied by the Avogadro's constant, which is 6.02 multiplied 10 to the power of 23, and the number of moles according to the triangle here, NM, MR, oh what is this, M, so N is M over MR, which is 62 over 31 multiplied by 4 because you're dealing with a P4. So you get the moles of 0.5 multiply 6.02 multiply 10 to the power of 23. So here you're kind of lacking knowledge and you just kinda link the L with any of the numbers you have here. So if you try to link it to a 62, you aren't really gonna reach anywhere. It's kind of useless. You can't find any relationship between the 62 and the L. But if you use it as L as being the Avogadro's constant, it also works because it's a constant. So L can be a constant and Avogadro's constant is a constant. So 0.5 multiplied that is basically Avogadro's constant over 2. So your answer is going to be C. Third question. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown in the graphs. What is the formula of the ionic compound formed from these elements? Okay, so we know that the big jump means it's going to the next shell, which is the more inner shell, because it has less shielding and it's closer to the nucleus, so it's a greater ionization energy to remove that electron. So if you look at the graphs here, this first one, it goes at pretty similar numbers till ionization energy 7 and then jumps a big jump to ionization energy 8. So that means it has 7 outer shell electrons, so it means it's group 7. Then let's look here. So it has 1, 2, then a slightly big jump if you consider it, and then it has pretty similar numbers after that. So we know that this one is going to be chlorine because it's in period 3 and group 7, so it has to be chlorine. Okay, so if you just cancel out these, it's going to be MgCl2. Pretty simple question. And this is magnesium because it has a jump after ionization energy 2, so it has 2 outer shell, and period 3, so it's Mg. But even if you aren't sure about this jump, because it might be kind of hard to tell if it's just going from like a more outer subshell to a more inner subshell, or a more outer shell to a less outer shell. So you just cancel out stuff other than chlorine because they aren't either in period 3 or not in group 7. So you just cancel them out and you're left with A. Fairly simple question. In which pairs are both species free radicals? So definition of a free radical is a species with one or more unpaired electron. This is important for paper 2 also. So Cl we know is a free radical. The Cl minus, it's not a free radical, we already know this from the organic chemistry. Because you know Cl cannot exist as atoms, only as diatomic molecules or ions. And if it's broken into atoms, then it's a free radical. So Cl is a free radical. But then we have to look at the oxygen now. Let's look at the atomic number of oxygen. Oxygen has atomic number of 8. So if we try to write the electronic configuration, 1s2, 2s2, 2p6. No, not 2p6, it has 8. So that's 4 already. So now we need 4 more and that's it. So if we look at the orbitals of the p subshell, 1, 2, 3, and then 4. It has 2 unpaired electrons, so O is in fact a free radical, so 1 is correct. So cancel out anything that doesn't have 1, so we cancel out D. Alright, and then let's look at 3. So this is a free radical, yes. And then let's look at oxygen. When it gains 1 more electron, it still has 1 unpaired electron, so 3 is correct. And then let's look at 4 now. So chlorine has an atomic number of 17. So basically it has a neon. So chlorine has an atomic number of 17, which is neon, which stops at let's write the full thing, it's better. 1s2, 2s2, 2p6, so that's 10. And then you have 7, so 3s2, and then that's 2. Now we need 5 more, 3p5. So now that's the electronic configuration of chlorine. So let's look at the orbitals here. 1, 2, 3, 4, and 5. So if you lose this, now it's even more of a free radical. So 4 is right, so it's A. 5. Which shape is correctly predicted by VSEPR theory? Number of bonded electron pairs, number of lone pairs. Linear. That's wrong. That's simple VSEPR theory. You know that. For example, water, the best example for this. 2 bonded pairs, 2 lone pairs. They push them down, so it's not linear like CO2, which doesn't have any lone pairs to push those bonds down. So it's non-linear. So A is wrong. Then number of bond pairs 2, number of lone pairs 2. Tetrahedral, no. Tetrahedral is only for 4 bonded pairs and 0 lone pairs. So B is wrong. And then C, number of bonded electron pairs 3, number of lone pairs 1. Pyramidal. So this is right. So let's look at it. For example, ammonia, NH3. So 3 hydrogens bonded to it, and then the lone pair that's here at the top pushes them all down. So that makes it a pyramidal, a trigonal pyramidal, makes it the shape of a pyramid. So C is the right option for now. Let's look at D. Number of bonded pairs 3, lone pairs 1. Trigonal planar, no. Trigonal planar has 3 bonded pairs, right, but 0 lone pairs. So C is the answer. In which species does the underlined atom have an incomplete outer shell? So basically a deficient atom. So BF3. So let's look at B, boron. It's in group 3. So it has 3 outer shell electrons shared with 1 fluorine. So it has an incomplete outer shell, because if it shares 1 with each, it only forms 6 outer shell electrons at the end. So it's missing. So A is right. But let's look at the other ones. CH3 minus. So let's look at CH3. Bonds here. And then carbon has 4 outer shell electrons, so here's 1 more. And then it has now 1, 2, 3, 4, 5, 6, 7. And then it gains 1 more from an external source, so now it has 8. So it has a full outer shell. Okay, let's look at the O and F2O. We already know this is gonna have a full outer shell, because you know water, it has 2 bonds similar to this, shares 1 each, and it has 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. That has an outer shell. C is not the answer. H3O plus. So let's make oxygen here the central atom, then here the 3 hydrogens. So this has a plus, so it has a dative bond. One hydrogen is gonna form a dative bond with one of the lone pairs, so here it shares one with each, basically water, and then you add a hydrogen to this water, you make this dative bond. So oxygen has 6 outer shell electrons, so before it was just sharing 2 of them and had 4 outer shell, now it shares 2 more, so it has 2 outer shell electrons now, like lone unbonded pairs. So let's count them: 1 2 3 4 5 6 7 what 1 2 3 4 5 6 7 8. Okay, my bad, I miscounted at the beginning. Okay, so D is not the answer, A is the answer. And if you know anything about incomplete outer shells, you know BF3 is like the best example for that, so you might have even known that before checking each option. In this question, it should be assumed that nitrogen behaves as an ideal gas under the conditions stated. Which volume is occupied by 1 gram of nitrogen at 50 degrees Celsius and pressure 120 kilopascal? Okay, so ideal gas equation PV equal to nRT, and here it gave you the mass instead of the moles. But you know, we know the equation of moles is mass over the mR, so mass 1 over the mR 14. And don't forget, it says nitrogen exists as a diatomic, and 2, so multiply that by 2. Let's calculate the moles now. 1 over 14 multiplied by 2, that's okay, that's a weird number. I'm just gonna say like the first half of it, 0.0357, and I'm gonna use the rest on my calculator to avoid any inaccuracies. I'm gonna store it and use it as a letter. Okay, so now we have the pressure 120 kilopascal and we need the volume. Okay, so the pressure 120 kilopascal. If you have kilopascal, you can use decimeter cube, and if you have pascal, you can use meter cube, but centimeter cube is not used at all. So these two work together. If you want to change from pascal to kilopascal and use decimeter cube, it's fine. If you want to change from decimeter cube to meter cube and use pascal, it's fine, both are correct. Okay, so 120 multiplied by the volume, which we're trying to find, and then the moles, which we found here, 0.0357, multiplied by R, which is 8.31. You have to memorize this. And the temperature, we have to always convert to Kelvin, 50 plus 273. So if you equate this, you can use shift solve for time purposes here in paper 1. It's better to use shift solve, it's way faster. So 0.0357 multiplied by 8.31 multiplied by 50 plus 273, shift solve, that gives you 0.7985, which is B. Consider the following 4 compounds. What is the order of increasing boiling point? So we know that the strongest IMF is hydrogen bonds, and hydrogen bonds are formed with OHs. So anything that has a polar part is gonna form a hydrogen bond. So here we can find this is an alcohol. Be careful of aldehydes. If they give you an aldehyde, they don't form hydrogen bonds, because the O has to be directly bonded to the H, which isn't present here. But in alcohols, you have the O bonded to the H directly, so it does form hydrogen bonds. So 2 is gonna have the highest, so it goes from lowest to highest. So 2 is gonna be the highest, so 8 is gonna be either B or D. Let's look at the weakest. The weakest is gonna be any branching. Branching makes molecules pack less tightly together and form weaker bonds together. So consider this example. So you have these molecules very far apart due to their branching, but if you have them straight instead, they pack very close together and stronger. So these are the SKF, cause it's faster. So this is going to have the weakest. So 1 is gonna be the weakest, and the answer is going to be B. You don't really have to bore yourself out of the SH and the other ones. Just know that the weakest is gonna be the more branching, the strongest is gonna have the hydrogen bonds. You can go from there. 8 is going to be B. Alright. 9. Ethane reacts with fluorine to produce 1,2-difluoroethane. What is the bond energy of the CF bond in 1,2-difluoroethane? Okay, so it gave you here the delta H, or the enthalpy change, and give you some bond energies here. So you know you can use bond energies to find the enthalpy change by doing the left side minus the right side. This is in simple terms, or in more AS level terms, the bond breaking minus the bond formation. Okay, so let's look here at the bond breaking. So I have C2H6 plus 2 fluorine atoms or molecules, and then you're forming C2H4 2F plus an HF. So here doesn't look like every bond is being broken, only a number of bonds are being broken. So from what I can see right off the bat, that the C2C bond is not being broken, so I'm gonna leave it on its own. It's a base there, and these 4 hydrogen atoms stay. They aren't being broken or anything. What you're breaking are these bonds and these, and then you're forming the HF and these C2F bonds. So let's form an equation here. So you're breaking 2 C2H bonds. Okay, so let's see the bond energy for 10. So there is 2 of them, plus the F to F plus 158 multiplied by 2. So now these are the bond breaking. The bond formation, now you're forming C to F bonds, which are, so that's what we're trying to find. This is X, so there is 2X plus the HF bond that's being formed, and there's 2 of them. 562 multiplied by 2. So let's form an equation and equate it to minus 960 minus these from each other, and then shift solve it. Okay, so let me just write this real quick. 2x plus 562 multiplied by 2 equal to minus 960, shift solve. So I got 486, so the answer is going to be C. So in bond energies and enthalpy change, you don't have to really break every bond. That was only in the IGC. I think even there's a question IGCSE where you didn't have to break all the bonds. So yeah, it's the same in AS. You don't really have to break every bond you see in front of you. You only break the ones you're breaking and form the ones that are being formed newly. So you keep the base ones the same, and you don't include them into the enthalpy change calculation. So 10. Which equation has an enthalpy change equal to the standard enthalpy change of formation of sodium oxide? So if we look at the definition of the standard enthalpy change, when 1 mole of a compound is formed by the standard, by the elements, my bad, by the elements in their standard states. It's important to say standard states, not standard under standard conditions. They're not the same. I've seen once an examiner report mentioning that they're not the same, and some candidates have lost their marks because of that. So it's better to say standard states. This is important for paper 2. I'm just dropping info here, and it's important for answering the question also. So 1 mole of the compound, so this wrong. These are alright, they check out on that point, but this is wrong. So it's either B or C. So let's look at the balancing. There are 2 sodium atoms, 1 oxygen, so have 2. Okay, that's correct, it checks out. And oxygen is gas, sodium is solid, oxygen gas, but then the balancing is off. There are 2 sodium here, 1 sodium, so B is wrong. 10SC. Nitrogen dioxide reacts with water to form nitric acid, and this. Which statement about this reaction is correct? Both products are formed because oxygen atoms gain electrons. Nitrogen atoms undergo disproportionation. The oxidation number of hydrogen is increased. Water acts as an oxidizing agent. Okay, so let's look at the oxidation numbers, because most of them talking about the oxidation numbers. Nitrogen has a +4 because each oxygen atom has a -2, so there are two, so it's -4. And the hydrogen is usually not changed unless it becomes a gas, like it forms a gas, because in element form it has 0, so that's the only time it's really changed. Other than that, it's usually the same, just +1. Okay, so I can tell that something is happening with oxygen because it has two different oxidation states, so there's gonna be some change. So here nitrogen has, so this is +1. Each oxygen is also usually not changed, it has a -2. So this is gonna be a -4. This is going to be -6. This is +1. So let's find the nitrogen now. The nitrogen is gonna be 0, 1 plus x -4. Shift solve. That's going to be +3. And then on the other one is going to be -6, shift solve, +5. Nitrogen goes from +4 to +3 and +5. So here it's decreasing by 1, here it's increasing by 1. So that's this proportionation reaction. And you can even cancel the other ones out, because it's water doesn't really act as an oxidizing agent. There's like not a specific thing that's going on here. It's not either reduction or oxidation, both are happening at the same time. Oxidation number of hydrogen is increased, no, it stays the same. Both products are formed because oxygen atoms gain electrons. No, not really, because if you look at this, yeah, it gains electrons, but this to this, no, it doesn't really gain electrons. So B is the correct answer. Because in MCQ, you either go by elimination, or you choose the answer that you know best, or you can definitely prove. There are other ones, if you can't prove them or disprove them, you put them on the side. If you can't disprove them, cancel them. If you can prove them right, you choose them. Alright, so phosphorus reacts with concentrated sulfuric acid to produce phosphoric acid, sulfur dioxide, and water. Okay, so here let's look at the oxidation number of sulfur. It's 6, and P is an element, so 0. Here it's +5 due to the extra hydrogen. SO2, that's +4 due to 2 oxygens. And then let's look at the oxidation changes, oxidation number changes. So here it's losing 2, here it's gaining 5. So now you have to balance the oxidation changes, oxidation number changes, so you have to make them equal. So you find the common factor and you do all of that. You can just multiply them by each other. So if you multiply this by 2 and you multiply this by 5, now you make them equal, which is 10. Okay, so let's now put the number that we multiplied with for each element. So we're gonna put 2 for each of the phosphorus and 5 for each of the sulfur. Let's look at the sulfur and the phosphorus if they're balanced. 5 sulfur, 5 sulfur, 2, 2. Let's look at the hydrogens now. You have 5 and 2, that's 10. And then here you have 2 and 3, that's 6. So you need more, 4 more. So here you have 2, so you put 2 here. Let's look at the oxygen. 5 and 4, that's 20 oxygens. And then here you have 2 and 4, that's 8 oxygens, plus 5 and 2, that's 10, so that's 18. And you need 2 more, 2 here, so you have it balanced. So it's going to be A is equal to 5, B is equal to 2, C is equal to 2, D is equal to 5, and E is equal to 2. Let's add them all up. 5 plus 2 plus 2 plus 5 plus 2, 16. Question 13. The volume of ammonia produced against time is measured in 2 experiments. In experiment 1, 3 mole of hydrogen and 1 mole of nitrogen react together at 45 degrees Celsius and a pressure of 200 atmospheres. A graph showing the volume of ammonia produced against time is plotted. Experiment 2 is then performed. So experiment 1 is the main one, the one that we performed here. And then experiment 2 comes after that. Experiment 2 differs from experiment 1 in only one condition. Okay, so it has a lower volume of ammonia produced. Okay, so let's look at the options here. An iron catalyst present in experiment 2. This would not lower the amount of ammonia, so this is wrong, because catalysts, they do not change the equilibrium position, and they only affect the rate, and they affect the rate of both the forward and the equally, and the forward and the backward equally. So there's no effect in the the concentration of the reactant or the product. So A is wrong. B, 2 mole of helium gas present in the reaction mixture in present 2. Helium gas is fairly inert, so if you increase the pressure by adding an inert gas, you increase the pressure and then it will move, but it won't really affect the rate, because here you have a faster rate in experiment 2 but a lower volume. So adding an inert gas, it does increase the pressure, but it doesn't affect the partial pressures of the reactants and the products. And for something to affect the rate, you need it to affect the partial pressures. So adding an inert gas doesn't really affect the rate, because it keeps the partial pressures the same as the volume is kept the same. A pressure of 250 atm is used in experiment 2. If you use a greater pressure, let's look at the moles. Here you have 4 and here you have 2. So if you increase the moles, you get more ammonia, not less. So C is wrong. D, a temperature of 600 is used. Okay, so if you increase the temperature, with the forward being exothermic and the backward being endothermic, so you move the equilibrium backwards more, so less ammonia. So D is right. Answer is D. 14. Which reaction has an equilibrium constant Kp that has no units? No units means the total number of moles on the right hand side is equal to the left hand side. That means they cancel on the Kp expression. So then let's look at the total number of moles. Here's 2, here's 2, correct, but let's leave it on the side. Let's look at the other options we have. 3 here, 1, that's 4, here's 2, nope. 2 and 1, nope. 3 and 2, no. Easy question. That was like a buffer question. I'm gonna solve till here, cause first of all it's getting late, second of all my iPad's dying. Gas Q decomposes slowly at room temperature. Okay, the Boltzmann distribution curve for gas Q at room temperature is shown. Which change occurs when catalyst is added? So first of all, you have to know that catalyst doesn't affect anything in the number of particles or the energy except the activation energy. So this will move here and that's it. Nothing will move, no peak changes, nothing. Peak of the curve, no. Number of the particles, okay, yes, because as the activation energy decreases, you have more particles with enough energy to decompose. Let's look at C. The kinetic energy of the unreacted particles increased. That doesn't even make sense. The value of activation energy decreases. Yes. Moving the vertical line to the right, no, that means it increases. It's contradicting. Answer is B. So that was it. I hope this helps. I'm going to post part 2 as soon as I can. Thank you.